For my final project, I did Pass the Pigs solutions using Elasticsearch. Pass the Pig utilizes two pigs as dice, and the rules are simple. On a turn, one player is required to roll the two pigs. Based on the landing position of the pigs, the player determines how many points they have accumulated during that turn. The player then can either pass the pigs to the next player and add to their point score, or roll again to add more points to their score. But should they land with both pigs with a dot showing up, then they lose all the points they accumulated during the hand. The first player to cross 100 points wins. Given the varied scenarios, it's important to understand whether to roll or hold the points one has accumulated. I will develop a dynamic programming model in Python to be able to solve for optimal strategies given the number of points in the player's hand, the opponent's hand, and how many points they have accumulated during the hand to roll or stop. I'll take the same data for the hand equity of each possible hand for 6,000 hands of Pass the Pig and load that data into Elasticsearch to see if the machine learning capabilities can find an optimal solution comparable to my Python dynamic programming solution. I've created functions to show optimal strategies along with what to do at any given point spread within Python using dynamic programming. The pipeline overview and technologies used. Collection tier. Elasticsearch with Python scripts in a collection notebook. Ingesting Pass the Pig data. Elasticsearch will be ingesting data from Pass the Pigs. Storage tier. S3. Store Pass the Pigs data within S3. The visualization tier, and I will use Kibana with Elasticsearch to visualize and correlate the hand equity data for Pass the Pigs. In conclusion, though Pass the Pigs is a simple game, the fact that one might lose all the accumulated points in their hand causes it to be a complex, dynamic programming problem. Understanding the equity in one's hand and whether or not to continue to roll or to stop and how that affects your potential to win is a similar problem to many other games, for example, backgammon or blackjack. And my Python model can be expanded to support those other games. If I create hand equity data in a form that can be ingested by Elasticsearch, I can generate a similar prediction within 30 minutes rather than the multiple days it took me to create the validation model in Python. But this requires me to generate data that could be trained and tested by the 3 ML models that were available to me in Elasticsearch. If I didn't have data in the format that would be easily managed by Elasticsearch, if it were not two-dimensional or not fully denormalized, I would not be able to utilize the models within Elastic nor the visualizations within Kibana without transforming the data. I have yet to leverage my program against online versions of Pass the Pigs or other human opponents, but I look forward to testing out the application to prove its value and collecting additional data to perfect my ML model within Elastic. Thank you very much.